Welcome to Manufacturing Talks with Jim Vinosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Hey everybody, welcome to Manufacturing Talks. I am Jim Vinosky, your host, and here we go. This is actually round 2. I screwed up big time, but we are off to the races now with my friends. I've got Jason Murphy from Next Generation Manufacturing and Brandon Teets from right here where we are at, Excel Digital Solutions. Welcome, fellas.
Thanks. Great to be here.
Okay, so the purpose of this, it looks very different to those of you who watch the show. We are in person here at Brandon's shop, which you see back in the background there. And these guys have both been on my Welcome to the Machine, my version of how it's made program, and talked about their 3D printing operations and what they do. And so we'll have a description in the link of those two shows and link in the description of those two shows so you can tune into those and learn a little more. But we want to talk more today about just 3D printing in general. And, it's not a new technology, but still in its infancy when it comes to production. And so let's talk a little bit about what sets it apart, where it is today, where you guys see it going. So start with you, Brandon.
Sure. Still in its infancy, yet being around for 40 some years, I guess. But still finding the opportunities with customers in an educational piece. Given traditional manufacturing, there's synergies, there's pros, there's cons, there's certainly differences. One I don't think is going to replace the other. There's significant value in both, but you got to, again, an educational standpiece, understand end use case of the product, volumes, and efficiencies that you can gain from additive manufacturing versus traditional injection molding, thermoforming, things like that.
Yep. How about you, Jason?
Yeah, I think, the challenges that the industry's had, anybody who follows the 3D printing industry now, there's just been a ton of challenges. Like last year was kind of doom and gloom, a lot of companies consolidating, going under, funds drying up. And I feel like, my take on it is that, there was a lot of people with a lot of solutions and not enough problems. And, when I started the company, it was really one of those things where it was out of necessity, right? We were solving a real problem, a problem that I had because I worked on the molding side and as a mold maker before. So it's something I dealt with. So I knew back when I started 3D printing like 27 years ago, I knew that was the solution. It was just the technology needed to catch up. So then it just became a matter of, educating people, opening people's eyes to it. So I think there's a huge opportunity going forward for people to learn. It's just another tool in the toolbox. It's not like we're saying, hey, we're going to take away machining or casting or molding. I think it's just saying, hey, look, here's another tool. If this is the right solution for your application, then use it well. So I think the other thing too is the amount of availability of resources within 3D printing, from material standpoint, the machines, the processes, within 3D printing, there's so many different sub-processes now. So I think that's just going to continue to explode.
When you think about, you've been around it for a long time, and that kind of illuminates how long it's been around. It's been decades, but it really started very slowly. I mean, it's a complete new production technology, got into prototyping, rapid prototyping. And I actually wrote an article last year about how I think people should be bullish about the production potential. But you also mentioned, I think it was you, Brandon, who said it's not going to replace these old technologies. And I think that's what drove a lot of the hype was I would hear again and again, well, it'll be proven when it replaces injection molding, which is just insane. It's not going to, and it was never intended to. It's not, to me, the serious people's eyes. What is it that 3D printing brings to the table that makes it a viable new technology?
Well, I think the materials, the exploration of materials just coming out, like, again, just in the metal side, when I started, there was like 5 materials out there, 5 metals, and it was like none of them worked for tooling. So I literally had to go back, as a mold maker, is like, if we're not talking true tool steels like H13,
Right.
P20, S7, 420 stainless, forget about it, because anything else, I don't want to, it's not going to work, because that's what we know works in the tooling world. So I think now we see this kind of explosion where, I had to develop the material and develop the process and the machines on open architecture equipment, a decade ago. Now we're seeing, a lot of this new materials, a lot of R&Ds there. And I think the same thing on the plastic side. So I think that's the biggest thing that I see, is the materials form that base, then to kind of explode the potential.
That's a great point. I mean, we always focus in on the technology, the machines themselves, but I know in our discussion for your pickleball, that materials played every bit as big, I guess, a role in that advance as did the technology. So talk about what that is an example. I know it's not everything you do.
Yeah, not everything we do, but it's, it's become a focal point for sure.
Yeah.
Being a fast growing sport for many different reasons.
Yep.
There's the environmentally sustainable aspect of it as well. But for us, we've been in business about a year now. And within that year, we've had the introduction of more than a handful different materials. Specifically, we have 2 in-house within the last 4 months alone that we've introduced. So in 4 months, 2 significant material introductions.
Wow. Yep.
That are different forms of nylon. So it's like, well, how many different forms of nylon could you possibly need or have? All dependent on the use case application of that part, what environment it's going to be in, and looking again how that value is brought from additive manufacturing versus a traditional manufacturing process.
Yep.
I think it's an accompaniment. It's not a replacement, right? So there's values for sure. I'd say there's setbacks for sure as well.
Yep.
It's not just a costing pricing scenario. It's not just a property scenario. How quickly you can bring it to market, how long it's going to last in the market, right? There's an umbrella and a family tree that goes a bunch of different directions.
Right.
And again, I keep hitting on the education piece, sound like a broken record, but it is a major, major part of, I think, the growth and the success of additive manufacturing to be everything that it deserves to be. Customer has to understand what the values of it are.
Yep. You mentioned in your beginning comment, efficiency. And I know that's another big, huge play that 3D printing brings to the table. So let's dig into that a little bit. What is it that drives the greater efficiency?
A lot of things. Loaded question, but yeah, a simple but loaded question.
Right.
The efficiencies are gained in a multitude of different ways. Again, going back to part geometry, specific durability, longevity, reusability, costing, timing to market. Those all play a factor in efficiencies.
Yep.
What is efficiencies to us versus what are efficiencies to the customer? They may be the same. They may be different. What are they looking for? What problem are we trying to solve?
Right.
Right. So once we understand that, we can further dive into what are the efficiencies that come from it. I mean, off of first thought, for sure, the material properties, the use of materials from an additive standpoint, you're gaining so much efficiencies there. Saves you time, right? You're not a subtractive, you're an additive process.
Yep.
And you're building exactly what you need when you need it.
Yep.
That takes out a lot of efficiencies, and that trickles into a myriad of different values of efficiencies, as I mentioned those before, right?
Yep.
Costing, timing, strength, durability, etc.
Yeah, for sure.
Yeah.
Jason?
Yeah, I think the efficiencies are really couple-fold. So one, like we just had a defense customer that came in and said, hey, look, we need speed to market, right? So they came in, they had 30 different iterations right out the gate. So if that was to be machined or had to be done by any other process, it would be, to make 30 different iterations would be months. The lead time would be that. We delivered that in a matter of days, and then they were able to test all those 30 at the same time.
Yep.
And then that condensed down that lead time. So again, speed to market is everything now. So getting parts out to industry or out to the market faster, that's a massive shift. So I think that's, the thing there. Efficiencies. So again, on the tooling side, in our tooling business, when we print something, now that might go through, a couple different stages, but the core process, the 3D printing, is all done at the same time. In a traditional billet, you're going to take a block of steel, you're going to mill it, drill it, EDM, surface grind it. It's going to go through all these things. And when we look at really what causes lead time and the weighting of that component, it's not the actual value add time. It's, waiting for this machine, waiting for that machine, waiting. So you stack that up. Now that's what drives those lead times and all those different processes that have to be done. Whereas we're building it all one. It's like setting the starting line, to 90% of the way done. And then, you still have, again, we're not saying you're not going to have to finish machine it. Typically you're going to finish machine it, or you're going to do some secondary op to it, but you're just starting closer to the finish line. So I think that has a big effect. And then again, the more complex it is, then the easier it is to finish, because then we're printing a lot of that in versus machining it and going through multiple steps.
The more complex is essentially reducing complexity, which gains all the efficiencies in turn.
It's a good way of putting it.
And I know one of the big kind of headline things you hear is the parts reduction, where traditionally manufactured thing might take 50 parts. 3D printing it might be 3 parts. But that also gets to the sustainability angle. And, I always say manufacturers don't get credit for doing sustainability since the get-go, because that's how we make our money, is being as efficient with our input materials as we can for what we make on the finished product. But additive also brings a whole new bag of tricks in that regard as well, right?
Yeah.
Talk about that a little bit, Jason.
Yeah, on the metal side, the sustainability or green aspect, however you want to do it, has a couple different, again, we look at multiple ways based on what is important to our customer. And then again, it's just about being good stewards of the material and the time. Again, we're very big into lean manufacturing, which doesn't get enough importance, especially in additive, right? It's still like, well, it's additive, it can be inefficient. And it's like, no, this is a business, we need to make money. So it's a matter of, how do we make things more efficient? But in the metal side, when we start with powder, so plastics start with powder for the most part. We start with powder, we load it in the machine, we run it, we recapture all that powder, we recycle it and reuse it. So we lose 1% of that powder, which then ultimately that 1% loss gets recycled. But we're able to reuse that 99% into the next builds. So what that does is it again, you're not taking that in a billet form like a traditional machine half of it away into chips, and then those chips get sold and recycled. But it's a lot of movement and transportation. You get 10 cents on the dollar. So those are things that I think that type of efficiency is very good. In the tooling side, so we make the parts with the conformal cooling. The conformal cooling then actually provides a reduction in cycle time. So now if I need to make 1,000 pieces and I can make them 40% faster because of the cycle time, now we're getting better utilization of our assets and the conversion factor. So again, for a lot of molders, the conversion, that's where they make their profit or lose it. Right. So if they can make it the same amount of parts faster, they're going to have better asset utilization. They're going to less labor, less energy usage. So I think all those things then go into being more sustainable ultimately. And what we find is actually we have a lot of our customers on the OEM side or the tier 1 side that utilize that and actually have a scorecard around that for sustainability, because that's what they're getting graded on. So it's very important. And we see the additive is a big contributor of that.
So just to clarify one point, Jason talked about that 1% that they kind of lose still is recycled. In a traditional technology, that might be 50%, 75%. And it's not like you lose that, but it has to go through a whole process of recycling, which adds energy inputs, adds transportation, adds all these contributors to non sustainable practices. I know for you, Brandon, we unfortunately in your world couldn't see the powders up close because they're actually a little hazardous and you have to have special handling. The one thing that leaps out as he was talking about what he does with your example is you were right there showing us the reclaiming of the plastics powder. So talk about it on your end around that.
Yeah, not an overly sexy process in terms of the workmanship or the thought about it, but it's sexy in terms of the reclaiming, the returning.
Absolutely.
So that sustainable term, depending on how you want to be graded, or you want to look at it or check that box. I mean, for us, it is important. It is everything about what we do.
Yeah.
So you start at a 80% reclaim, a 20% virgin that goes into a build. Obviously, you're able to see a further cost reduction. This is specific to our technology, the multi-jet fusion through HP.
Yep.
And reclaim as much as you can. That goes back into another build, right?
Yep.
And the thing about sustainability is it's not degraded powder or material. It's not beaten down, broken down, so that the sustainability of that's come full circle and be added again for another build at 100%.
Just going straight back into your process.
Optimization is key.
And that in your world is that 99% is just going straight back in.
Yeah.
No additional handling, just right back into making more stuff.
Yep.
And I think Jason alluded to the fact that it's not just sustainability of the process or what's in with their four walls. He's added that, right? And we add that too for our customers on through the delivery of products to them and through their processes, right?
Yep.
Whether that be material handling, the overhead, I mean, all the costing, time, essentially waste that goes into that is reduced with the ability maximizing additive manufacturing.
Yep. Excellent. I know another piece of any new technology obviously is you're coming at things now from a whole different thought process, right? So talk about kind of the design end and how the new technology changes what you do, even when you're conceptualizing what it is you're making.
Sure. I'm going to steal this for a second, but I'm going to give credit, right? It's as Jason said, it's forgetting traditionally what you normally do to be able to optimize what the art of the possible of what you could do, right? Again, I stole that. Jason mentioned
steal
earlier.
with pride.
So, I think that's
you get credit.
it's a good analogy. And how to just level set everything and go back to the basics. I think a lot of people maybe say, there's no such the dumb question, but honestly, asking the dumb questions that you would think are traditionally dumb in this scenario are good questions.
I always say there are no dumb questions. There are just dumb people. Sorry.
That may be right. You can't teach common sense. You have it or you don't. But all these analogies, I think, circle back to what additive manufacturing brings to the table. And I mentioned this previously. I'll mention it again. It's an accompaniment. It's another tool in the toolbox. Again, stole that. But how do you look at, and we start from the other side, what's the end use case of that part?
Yep.
Yeah.
And then we can say, how do we look at designing it, engineering it, manufacturing it?
Yep.
When they say the material might be a nylon, and we look at it and say, well, why? Why is it a nylon? Can it be these other things?
Yeah.
Right. There's obviously importance of understanding the properties that it's going to be within that environment of that part. But could it be an elastomer? Right. Could it be a different nylon? And so we bring that value. I think it's come a long way. Like I said, in the last even 6 months for us, there's new materials that we've subbed in and brought to the customer, said, here's the value of this. And so happens it's easier to process, costs less per kilo, right?
Yeah.
So when we're able to save them money, I mean, that's a win, along with delivering what we see as a better part to them in that end use case.
Yep.
I think you hit the nail on the head. I mean, it's a solution, right? We try to just listen to our customers and listen to I know this is what you're asking me for, but this is what I'm hearing, right? And if customers come in and they say, well, here, I just want this part printed, we're probably not your guys, right? Where we partner with our customers to really listen, understand, we're problem solvers, so we're bringing a solution. You guys have solution in your name, so that's it. It's like we come at it with bringing you a solution, understanding the problem, because if you don't understand the problem first, if we don't have a good grasp of it, we can't bring the right solution. So I think, from that aspect of it, we have to look at it from what problem are we solving? And then we come alongside of our customers by understanding their problem. Is just that, we have a lot more experience, and by experience, or, I don't claim to be an expert, but we've just made more mistakes than everybody else, I think is what I classify it as. So, we bring all that experience to our customer, and that's what they love about it, working with Next Chapter, is that, we're coming in, I've worked with these guys for a long time. They're the same mindset as like, problem solving and coming up with those solutions and looking for a better way. And then using the available resources. So it's the machine capability, it's the material capability, it's software, so the ability to design something, it's, again, if you came in and you look at, again, like the pickleballs, it's how a traditional pickleball is made or designed and structured is very different than what your guys is. And that took some understanding, but that design has a very specific purpose. Our parts have very specific purposes. They're solving a very specific problem. So a lot of times our customer says, well, I didn't even ask for that, or I didn't know that that was possible, but this is really what you're solving. Because we know a lot of times, again, there's a lot of people just getting into 3D printing, but they haven't, maybe they come with a solution, but they haven't thought about how you're going to maintain it. And our tooling maintenance is just as important as actual building it. So like, how are you going to maintain it? How are you going to do it? So we're in it every step of the way with our customer to guide them and make sure they're going to be successful. If they have a bad experience, forget it. They're never going to do it again.
And you made me think of a point that everyone out there should be thinking about is everyone really needs to be looking at 3D printing as an option and exploring whether it has something to offer, right? If you're not doing that right now, you're probably falling behind. Even if you reach a point where you say, you know what, right now it's not the right answer for us. If you haven't asked that question, you could be missing a big opportunity.
I think it's going back to the traditional thought process of traditional design, engineering, and manufacturing. It takes this much time. So if we start it, we're not going to see that. So we got too many irons in the fire. We don't have the resources that we need. The glory of it is it, voids all of that.
Well, and to the resource point, you guys are the resource.
Exactly.
And that, I think, again, doing this for a number of years, there's customers that we talk to, and they're just not there yet. Like, hey, look, this is not for us, or we're going to stay a little conservative. But really in the last, year, 18 months, it's just been a crushing wave of transformation. People moving from traditional methods into additive for various reasons. But again, it's their reasons. And it takes getting to your reason or your why of why you need it to really be able to make that transition. But what we do see is we see this just, kind of crushing wave of new work coming in from people that maybe weren't there a few years ago. We do a lot of trade shows. I speak at a lot of conferences, and, people say, well, I'm just not quite there yet, or projects, we'll quote something that dies. Hey, guess what? It's on and it's hotter than ever. Why? Because they never really solved the problem originally, right? Like they're just fighting with it. But now it's like, okay, now we've squeezed every other, bit of profitability out of this job. Now we got to get to the next level. So I think everybody is on that journey, but I think you're right. You have to be on that. You have to be looking at it again it's just another tool in toolbox, but you still have to be considering it to say, look, where does this fit within the strategy of our company, and how should we be looking at it to maximize our efforts? So again, maybe we still do this part in traditional machining, or do we do this in molding? But look, we have an area that complements this part of the business that we need to be doing additive in to grow their businesses as well.
Well, it's that domino effect, the snowball effect. When they do spend the time, or they allow the opportunity to listen, right, to folks like us, express to them the value, then they start putting everything together, and the wheels start getting in motion. And then it's, in a good way, a very dangerous thing. Again, it's educational piece. It's resetting the norm. And there is no more norm.
Well, right. And upset the apple cart.
And that's a good point too. I was telling Jim earlier before he started that I had the chance to visit one of the technical schools here in town a couple weeks ago, and I was just blown away because, you know, you go in and there's literally rooms full of 3D printers. There's rooms full of, you know, cobots and robots and CNC machines. And it's like, man, you know, like where was this when I was in school, right? But really when you look at it is like, this is the thing that the next generation, this is the only thing that they know. They know this new technology. They grew up with it. So, you know, whereas I think, you know, again, there's maybe a chance, or what happens, what we see a lot of times, a lot of that gets suppressed in business because it's like, well, you know, the most senior guy is the guy with the best ideas. And really, you know, we really need to be paying attention to those, the next generation coming in, because they don't have all those limitations like we do, you know, as old guys, you know, we have all that kind of baggage, right? You know, so I think listening to the next generation, seeing them coming in trained, gives me a lot of hope. You know, I know there's kind of a big thing of like, you know, a manufacturing crisis or a labor crisis, but it gives me a lot of hope knowing that these young individuals are coming in and embracing it already. We don't have to teach them.
Well, good deal. Well, we are just about out of time, fellas. So closing thoughts. Start with you, Jason.
Yeah, this has been a great discussion. You know, I think, again, looking at how does this additive, how does it work for you in your company? You know, I think that's really it. You know, I would, you know, again, as Brandon mentioned several times, big into education. I'm big into education. You know, this is why I speak and write articles and things like that. This is why we're doing this today. Educate people, get the word out. So if you're, you know, it can be intimidating. So just, you know, reach out to one of us or reach out to somebody you see as an expert online and engage, you know, and educate yourself. Do a lot of reading, study it. You know, I think experimentation is also the other thing. Don't be afraid. You know, you're gonna make screw ups. You're gonna make mistakes. So just do it. But you know, the sooner you do it, the better you become faster. So start making mistakes, start learning, start doing it. If it doesn't work, great. You're on the right path to it working for you. So I think start and just get going, and you know, you'll find your way.
Excellent. Brandon.
There's no right time.
Yeah.
But the time is now, right? Every day, every minute, every hour that you let go by, somebody else is advancing, doing these things, leveraging that. We're here as a resource, right? We really enjoy what we do. We have fun doing it. As much as you may think there's not an application, I promise you there is, right?
Yeah.
And so it's get out there, ask those questions. There's more synergies than people would believe from an industry or product that they don't see is similar to theirs. And that's where we add the value, right? We see the benefits of how we leveraged that part for that customer and that industry. But what we do here, we design and engineer maybe a little bit differently, but we produce off the same equipment, a similar or the same material. But it may be for 5, 6, 7 different vertical industries that are not the same.
Right.
But the mindset and the process is very similar, if not the same.
Well, and as you were talking, I was thinking, even if someone tried a year ago and found the answer, it wasn't right then. Things are changing daily on this technology too. So
daily.
Don't think because you looked at it a year ago, it's not the right answer today. Thanks so much, guys. Just a really, really educational discussion. So
thank you, Jim.
Brandon, especially thank you for the really cool background. And so Brandon Teets with Excel Digital Solutions and Jason Murphy with Next Generation Manufacturing. Really appreciate you guys joining me today. And of course, as always, thank you guys out in the audience. You are why we're here. And we're here every Tuesday, sometimes even more. And of course, we've got the shows like these guys help me with on the Welcome to the Machine playlist. Check that out as well. I will include the links to their shows in the show description. And tune in next time. We'll be here for you. Thanks, and so long from Manufacturing Talks.
Thank you.
Thanks.
Thanks for tuning in to Manufacturing Talks with Jim Benoski. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.